Howdy! Welcome to Aspire Mountain Academy. I am Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides extra practice finding and using critical R values. Now, in the previous mini lecture, we learned about critical R values and how we can use them to assess more objectively whether an association between two variables in our data set is strong enough to conclude they're correlated. Now, let's look at some more examples of that. First up, we have Michael Bay movies. Any Michael Bay fans in the house? Well, you're obviously not in my house because I really don't care for Michael Bay movies. No offense if you do. I just think they're too formulaic, among other things. Anywho, someone decided, hey, let's look to see if there's a connection between the number of explosions in Michael Bay movies and how much each film grossed at the box office. So people collected the data, found a linear correlation coefficient of 0.941. And now we're asked, what are the critical values of R, and what can you conclude about a linear correlation? Well, remember from the previous mini lecture, you'll typically find critical values of R from a table. Here's our critical R value table. So, what's our critical value of R? Well, if you don't remember how to use the table, remember that you first find your sample size. Our problem statement says we have 11 pairs of data, so our sample size is 11. We look in the table and we find that value right here. Then we just look across the same row in the other column of the table, and there's our critical R value, 0.602. But remember, we have two values for critical R value, so one's positive and one's negative. The table is just listing the positive value, so don't forget the negative one. Now, that answers our first question. We'll answer the second question by comparing our critical R values with the R value we get from the data. So, here's our number line with our critical R values. All we need to do now is add in the R value from the data set. What is that number? Well, here in the problem statement, we see that the R value from our data is 0.941, which would place it here on the number line. Now, what region are we in? Well, we're in the region of positive correlation, which is the region of acceptance on the positive side. Therefore, we can conclude there is sufficient evidence to support a claim of linear correlation between the number of explosions in Michael Bay movies and how much the films gross at the box office. Now, given these results, can we say that Michael Bay should put more explosions in his films if he wants to make more money? I'll give you a moment to respond. Well, remember that correlation is not causation. Just because the number of explosions is correlated to how much money the movie makes doesn't mean that the one causes the other. It just means there is some association between the two variables. It says nothing about what that association is. There's more complexity to Michael Bay films than blowing things up, although I would argue there's not that much more complexity. To discover more about what that relationship is between the number of explosions and gross profits, you need to conduct further study. Okay, let's look at another example. This one involves the heights of fathers and sons. Someone collected the data and found a linear correlation coefficient of negative 0.017. You can find the data in our class StatCrunch group, so feel free to pause the video here and go open that file so you can follow along in StatCrunch if you like. I'll wait for you to open the file, and then when you come back, I'll show you how to use StatCrunch to find the linear correlation coefficient. Okay, here we have a quick video in which I show you how to find the linear correlation coefficient for paired data using StatCrunch.
Okay, we're here in the data file for father and son heights, and we're going to learn how to calculate a value for R, the linear correlation coefficient, inside StatCrunch. So here's my data set. To do that, I'm going to go up to Stat, Regression, Simple Linear. I need to add in my X and Y variables. The X variable is typically the one that's listed first. And then we don't need any of these other options for the simple R value, so press compute. And here in my results table, there's a lot of information here, and we'll go over all of this later on in the course, but for right now, we're just looking for our R value, which is listed right here at the top of the table, negative 0.017. There it is. That's how it's done.
Okay, let's return to our sample problem. We saw we have 10 pairs of father-son height measurements in our data file, and they give us negative 0.017 for our R value. And so now we're asked, what are the critical values of R, and what can you conclude about a linear correlation? Well, to find critical values of R, we'll use a table. Here's our critical R value table. So what's our critical value of R? Well, remember, first find your sample size. From what we saw in the data file, we have 10 pairs of data, so our sample size is 10. We look at the table and find that value right here. Then we just look across the same row in the other column of the table, and there's our critical R value, 0.632. But remember, we have two values for the critical value of R. One's positive and one's negative. So the table just lists the positive value. So again, don't forget the negative one. Now that answers our first question. We'll answer the second question by comparing our critical R values with the R value we get from the data. So here's our number line with our critical R values, and all we need to do is add in the R value from the data set. And what's that number? Well, here in the problem statement, we see that the R value from our data is negative 0.017, which would place it here on the number line. Now, what region are we in? Well, we're in the region of no correlation, which is the region of non-acceptance. Therefore, we can conclude there is not sufficient evidence to support a claim of linear correlation between the height of fathers and the heights of their sons. Well, what would explain the lack of a relationship here? Well, height is a genetically determined characteristic of an individual. Are all those genes coming from just the father? No, the mother makes a contribution as well. And the height, data on the mothers was not included in the study. So here we see that the lack of correlation means there's no direct relationship between our two variables alone. We must consider other variables as well to better understand what relationships may be present. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.